Good morning. Today we're going to be evaluating logarithms. We first are going to go through the definition of a logarithm, and then we're going to start to evaluate different logarithms on example number 2 and example number 3. But before we actually start, let's go over exponents first. We'll learn in this section that logs and exponents are related, especially as we go through the definition. First, 3 to what power is equal to 9? So 3 raised to what power is equal to 9? That'll be 2. 3 to the second power is equal to 9. 3 to what exponent is equal to 27? We know that is equal to 3. 2 to what exponent is equal to 8? We know that will be equal to 3. 2 times 2 times 2 is equal to 8. 2 to what exponent is equal to 16? So 2 to the 4th power. 5 to what power is equal to 125? We know 5 to the 3rd power because 5 times 5 times 5 is equal to 125. And 10 to the 2nd power is equal to 100. Now we need to be able to estimate the exponent for each of the following bases to make it true. And we're going to be using a calculator just to be able to get a little more approximate value. I know that if I use a calculator, I'm trying to find the exponent. I know that 2 to the power of 2 is equal to 4. So that's a little too big. So let's try 1.5. 2 to the power of 1.5, I'm looking for it to be equal to 3. It's 2.8. So let's go 1.6 instead. 2 to the power of 1.6. That's actually pretty accurate. So exponent will be about 1.6. If you guys notice, it's not an exact value, and it's going to give you a fraction. This is the first time that you guys have seen fractions as the exponent. Now, 2 to what power is equal to 7? I know that 2 to the 2nd is 4, so it's a little too low. Let's try 2 to the 3rd power. 2 to the power of 3 is equal to 8. That's a little too high. So let's try, instead of 3, let's try 2.8 or 2.9. So 2 to the power of 2.8, that's actually not bad. So that'll be 6.9. If you round it up, that'll be 7. So that'll be 6.9. I'm going to do one more with you guys. 2 to what power is equal to 13? So 2 to the power of 3 is equal to 8. So let's say 2 to the 4th power is 16. So that's a little too high. So let's try 3.5. 2 to the power of 3.5. That's 11. I'm looking for 13. So 2 to the power of 3.7. 12.99. So that's not bad. So let's say that's 3.7. 2 to the power of 3.7 is going to be 13. Now go and continue on each one of them and see what you get. Go and pause it, continue on and see what you get for each one. So if you had done each one of them, we could have done 3 to the 1.9 is equal to 8. 3 to the power of 2.1 is equal to 10. And if we continue on, if you guys notice, it's a little work just to be able to estimate the exponent if it's a decimal. Now, I kind of did cheat a little bit because I used the table of logs that you guys have on the back. For example, if I want to be able to find out 5 to what exponent is equal to 50, I'm going to look at the log base 5 because this is the base 5 and I'm looking for the exponent. I'm going to go over to the base 5 and I'm looking for 50, and that is 2.4. So the exponent is 2.4. In the same way, if I'm looking for 10 to y exponent is equal to 90, I'm going to have to look for the base 10, log base 10, which is basically the common log. If it doesn't have a base, we'll learn that it's automatically a 10. So under the common logs or the base 10, I'm looking for the 90. So I'm over to log of 90 is 1.95. Ten to y exponent is 95, so I'm looking for the log base 10 of 95. So I'll be 1.97, and 10 to y exponent is equal to 99, so this will be 1.99. You also have the capability to do that in your calculator. We only have log base 10 and log base e, which we'll see in a few minutes. We can do log, and if we're looking for, and the log is right here, so log of 95 will give us 1.97. Log of 99 will give us 1.99. But let's go over the definition of logs. The logs can be written as exponential form. And let me just illustrate it for you guys. We basically can rewrite the log. The b becomes the base. So the log can be written down as an exponent. Let me show you guys once again. The base for the log, this base, becomes the base for the x. So let me show it to you guys once again so you guys can visualize it. Basically, this is the base for the log, and it becomes the base for the x. The logarithms with base 10 is called a common log, and is the log base 10, but as we mentioned before, if there's a 10, automatically we don't write anything because we use it so often. The natural log is log base e, and we write it down as ln. So whenever you see ln, it's basically the log base e. On the first example, let's go and rewrite from a log to an exponential form. The only thing that we're going to do, we're going to bring down the 9. The 3 becomes a base for the 2. On the next one, let's go and rewrite it. This is a 1. This 19 is the log base 19. It becomes the base for the 0. And let's go and try the last one and see what you get. Go ahead and pause it. So this will be 32 is equal to, the 2 becomes the base for the 5. We have two special values for logs, which you have to memorize. Log base b of 1 is equal to 0. So every time there's a 1 in here, it's equal to 0. That is, if we rewrite it, this will be 1 is equal to b to the 0 power. It doesn't matter the value of b, anything to the 0 power is equal to 1. So if there's a 1 in here, automatically it's going to be equal to 0. Also, if the base in this number here is the same, it's going to be equal to 1. If we rewrite it, this will be b is equal to b to the 1. The b becomes the exponent for the 1. So it doesn't matter if those two numbers are the same, it's going to be always equal to 1. So I want you guys to highlight it, so that way you guys can remember those two values. So let's go and evaluate the following expressions. Example number 2. Log base 5 of 1. We know that if this is equal to 1, automatically they're equal to 0. Can you guys find any other ones that are equal to 0? Correct. So letter D is going to be equal to 0 because there's a 1 in here. Letter E, there's a 1 in here, so automatically it's equal to 0. For letter B, if the base is equal to this number here, it is automatically equal to 1, just like we saw here. And if you want to be able to rewrite it to confirm, you can. Remember that automatically, if there's no base on the log, automatically there's a 10. So log base 10 of 10, that will be equal to 1. Letter F can be written down as the log base E. Ln stands for the log base E of E, because the base is the same. It's going to be equal to 1.